Wonder why we can't see in the dark? Well, that's because there's no light.
But what is light? Is it the sun?
Is it a machine? Or is it just light? Nothing more, nothing less.
So many questions we're asking. Let's find some answers now, shall we?
Well, to answer our first question, light is a form of energy. And energy is what makes things work. For example, you need energy to walk around outside. Without energy, you would just feel very tired and you wouldn't be able to do anything. The energy you get to move around is from eating, and it's called chemical energy. Similarly, light energy is what allows us to see the world around us. The sun produces light, and so do the lamps and light bulbs in your home. Without any of these, we wouldn't be able to see anything. There's a lot of different ways we can see light and not even notice it. To understand this, it's important to know that the material light is passing through is called a medium. When you look into water, the medium for this particular light, you can see a reflection, which is a change in the direction of light away from its original path. But when light travels into a different medium, it sometimes changes direction a bit slower. This is called refraction. Depending on the medium, light can pass through in different ways. Opaque describes mediums that absorb light, meaning light can't pass through it, and instead you see a shadow, such as walls or a door or books. Transparent, on the other hand, is the opposite of opaque. It means that light passes through it completely, like glass. Translucent is in between. It means that a little light can pass through, but not all of it, meaning that the light has been scattered and makes the objects on the other side of the medium blurry, like tissue paper and frosted glass. So how can we demonstrate refraction easily? Here's a fun experiment that you guys can do at home. We'll be seeing how refraction works by using these two glasses, bottle caps, milk, and water. Before we start, let's go over the scientific method. Problem, hypothesis, materials, procedures, results, and conclusions. This is important because this is important to use whenever we want to conduct scientific experiments. So first, let's identify our problem. In this experiment, we want to know which liquid will make the bottle cap disappear. Next, our hypothesis. What prediction can we make using the knowledge that we have right now? The form the hypothesis will take is that your hypothesis will take the form of if blank has the same refractive index as the glass beaker, then the bottle cap will blank. Oh, goodness. The refractive index measures how quickly light passes through a substance. So take a few seconds to fill in the first blank with either water or milk, and then fill the second blank in with either appear or disappear.
12 seconds later.
Now it's time to gather the materials. For this experiment, you'll need 2 small clear glasses, 2 bottle caps, make sure they're not clear, some milk, and of course a glass of water. You'll be using one of the glasses for the milk and one of the glasses for the water. Once you've gathered your materials, you're ready to start the experiment. Now for our procedure. First, let's start with the water beaker. Take your bottle cap and put it into the water beaker like this. Then, take your water and slowly start pouring the water until it completely submerges the bottle cap. We notice that we can still see the bottle cap through the glass even after the water submerges the bottle cap. Now let's move on to the milk. Take your bottle cap and put it in the same way as you did before. Then take your milk and slowly pour it until it submerges the surface of the bottle cap. Now when we look through the glass, we see that we can no longer see the bottle cap. So what are the results of this experiment? What did we notice? We noticed that when the bottle cap is placed into the beaker with the water, we can still see the bottle cap through the glass. However, when we take the same bottle cap and place it into a glass of milk, we notice that we can no longer see the water. However, when we put the same bottle cap into a glass of milk, we notice that we can no longer see the bottle cap, even when we put it into a glass. So, what can we conclude using those results? What we can conclude from this is that the refractive index of milk is very high, and thus, light does not pass through it easily. Therefore, we can't see the bottle cap. Water, on the other hand, has a very small refractive index, meaning that light passes through easily, and we can easily see the bottle cap through the surface of the glass. So now, what future directions can we take? Try to find 2 more substances that aren't water or milk that have similar refractive indexes and try the experiment on your own. Now let's move on. Another form of electromagnetic radiation is ultraviolet rays, also known as UV rays. Their wavelengths are actually different from that of visible light, so we can't actually see these. However, the sun emits them every single day. Unfortunately, these rays are hazardous to our skin. That's why we wear sunscreen to protect ourselves. Now, are y'all ready for another question? In this experiment, we're going to be demonstrating the refraction of light. For this experiment, you're going to want a glass full of water, make sure it's full to the brim, a sheet of paper, and a solid colored marker. What you're going to want to do, take your marker and draw 2 arrows onto the paper. Make sure they're both pointing into the same direction. Color them in as best you can. You gave me a dead marker. Perfect. We notice that both the arrows are pointing into the left direction. Now, slowly take your piece of paper and hold it above the surface of the water. Now slowly move it down. What do we notice? The arrow is now pointing into the right direction. It's not? What happens if we slowly move the arrow to be behind the glass? We notice that the arrow is no longer pointing into the left direction.
We don't see anything!
What happens if we position the arrow such that it's behind the glass? Let's try it.
Down. Left. Down. Yes.
So, what do we notice? We notice that the arrow that was previously pointing left is now pointing to the right. So what's happening? Is this a magic trick, or can we explain the science behind it? So what's going on in this experiment? The scientific concept that's at play is called refraction. Refraction is the bending of light, and refraction occurs when light moves from one medium to another. So in this experiment, the light moved from the image into the air, from the air to the glass, from the glass into the air until it finally reaches our eyes and we see the image. However, when light refracts through different mediums, it moves at different velocities, meaning different speeds. Light travels fastest when it's moving through air, a little bit slower when it's moving through water, and the slowest when it moves through glass. This means that light refracts different ways at each medium. This means that when we see the image, it's flipped horizontally, so the arrow, instead of pointing to the left, is now pointing to the right. Well, say we learned about light, and also learned about refraction and reflection. Can you guys think of any other experiments we can do to demonstrate how light works? Put them in the comments below. Thanks for watching. This was Shrika and Sai from SciVids. Keep sciencing on.